It's such a pleasure to be here, and it's also really weird to hear your bio being read out loud. I remember I was at church once, and I was next to a friend, and the pastor was reading my bio, and she said, "Wow, that speaker sounded really impressive." And then I realized it was just you. So that was always a fun experience. But today I'm really excited about what we're going to talk about, because we've been talking a little bit about more the philosophical framework of science and faith, and you heard last night an easy introduction to the biology. And what I'm going to talk about is more of the physics, the cosmology of the universe. Really, really big, way big. And then the next talk, I'll talk about the cell, way small. So we're going to hit the whole gamut. And this is really a topic that's dear to my heart, because I was raised in the church, but I went to MIT undergraduate, and I read Richard Dawkins, his book, The Blind Watchmaker. And for those 2 or 3 in the room that don't know who Richard Dawkins is, he's one of the patron saints of atheism. So he's wanting to eradicate religion from the planet. And for a moment, at the time in college, I became pretty convinced that science had shown that faith was simply a psychological crutch. That you really had to be one of 2 types of people. Either you were a person of faith, and you sort of believe things blindly, and you sort of had sort of a soft, fuzzy sort of logic going on, or you were a person of science, that you believed in facts, you believed in evidence. And that was really disheartening. And that put me on this quest, because I realized if there is no creator, if I'm simply here as an accident of nature, there's no point to life. It doesn't matter if I'm happy or sad or kind or cruel. I will die, and then my memory will be lost. Eventually the planet will explode and all life will be ended. And even if we can colonize other planets, which is really unlikely despite what you might see in Interstellar, eventually the universe will run out of energy and all life will end. And those are pretty dark thoughts as a freshman in college, but that's where I was. So I went on a quest to figure out what was actually true. I studied physics and chemistry and biology and many other disciplines. And what really was interesting is I realized that a little science can bring people away from God, but a lot of science will bring them right back. So I'm going to talk a bit about the issue of cosmology. And particularly, we're going to talk a little bit about the origin of the universe. And what was fascinating, if you look at Greek philosophy, don't worry, I won't talk about it, but if you happen to, a lot of them believe that the universe was eternal. And because the universe was eternal, and you have all these immaterial atoms bouncing around, anything is possible. So everything you see in the universe that looks designed is simply a product of chance and time. And that was something that even as late as the 20th century, a lot of scientists thought the universe was eternal. And what shocked them was they figured out that it wasn't. Because if you look at general relativity, and you look at Einstein's theory, and you look at the fact that you have this cosmic redshift and light coming from distant stars, people realized the universe had to have a beginning. And that was shocking, because the implications are dramatic. Many physicists resist it, because if there was a beginning to time, space, matter, and energy, something had to begin it. Nothing starts itself. We don't see Coke cans just pop into existence all by themselves. So there had to be something outside of time and space that was infinitely powerful, that could create our universe in a burst of light. Doesn't that sort of resonate with a religious text? I don't know, just something comes to mind. So what you find is cosmology points back to the creation event described in Genesis. In the beginning, God said, "Let there be light," and there was light. Well, this was shocking, and many physicists were trying to resist the implications, but eventually it won the day. Well, what was fascinating is, if you remember a few years ago, there was a few books that came out. One was The Grand Design by Stephen Hawking. Another was The Universe from Nothing. And these were physicists that were arguing that you don't need a creator. The universe could just create itself. In fact, there is a famous quote from Hawking's book. He said, "Because there is a law such as gravity, the universe can and will create itself from nothing, Spontaneous creation is the reason the universe exists, why we exist. It is not necessary to invoke God to light the blue touch paper and set the universe going. This was a bold claim. In fact, I believe Hawking said we've sort of transcended philosophy and religion, and now science has ruled the day. Well, I have learned through the years never to trust what anyone says publicly. I always go back to the original literature. So what I did was I took a lot of time to actually go back to the original papers by Hawking and Hartle. And what I'm about to show you is the actual research that this is all based on. So here's the paper. It's this famous paper, talks about the wave function of the universe. And what they were doing is they realized that when the universe gets really, really small at the beginning, that general relativity and quantum mechanics have to work together. And that's really hard because they seem to be completely incompatible. So one of the big frontiers of science is what's called quantum gravity or quantum cosmology. And that's what this is about. So if you actually look at the equations in the paper, and for those of you that may be math phobic, I encourage you to look away. This could create a panic attack. But for those of you that may happen to have studied general relativity, I'm sure you'll appreciate this. So when you look at the equations, what you find is it's an action integral, it's a path integral, is that the equations do not describe a universe literally coming from nothing. What these equations describe is a universe that starts in essentially infinitely small volume, and then it will evolve with time. It will transform into a small state, which is where quantum mechanics no longer applies, and that's where general relativity takes over. Key point. The equations do not describe a universe coming from nothing. They describe a universe which already exists and then changes with time. So when people like Lawrence Krauss say it's a universe from nothing, it's equivocation, it's doublespeak. The nothing is not nothing. The nothing is a pre-existing universe that has already come into existence. That's key to realize. Now, and that's important to realize because when you hear things like scientific laws, equations, what those equations do is they describe what happens in the real world. The law of gravity describes what happens when an apple falls to the ground or a laser pointer. The laws don't cause my laser pointer to come into existence. It's the same thing. The equations that describe the early universe do not bring the universe into existence. They simply explain what happens when the universe is already here. Now, what's happened is you have some Hawking and even Vilenkin, who did the other paper that inspired Krauss, have pondered the idea of the equations having an independent existence. Here's an interesting quote by Hawking. He said, "What puts fire in the equations and makes a universe from them to describe?" He's wondering, how can this work? How can equations exist outside of time and space? Well, Vilenkin is even more explicit. He says, does this mean that the laws are not mere descriptions of reality and can have an independent existence of their own? In the absence of space, time, and matter, what tablets could they have been written upon? The laws are expressed in the form of mathematical equations. If the medium of mathematics is the mind, does this mean that the mind should predate the universe? This is an atheist, but he realizes for mathematical realities to exist before the universe, they can only exist in a mind or a creator. So when you look at these cosmological arguments, when you read Hawking, when you read Lawrence Krauss, and they say that we've explained the universe come from nothing, they are not being accurate. What they've done is these equations point to the mind of a creator. That's key. Now, there's even more, because it's not just that the origin of our universe points to a creator, but as scientists have studied the laws of nature, they've realized that they seem designed for life in mind. Now, let me illustrate. Imagine for Christmas, you get a little universe starter kit. Or I guess for modern day, it's on your app. You've got your universe starting app. There's all these dials, and you can create your own universe. You can control all the details. You can make gravity stronger or weaker. You can control the mass of an electron, make it bigger or smaller. You can control the early disorder of the universe. It's awesome. So you start, fiddling with your dials. Boom! You create a universe in some sort of Doctor Who type chamber, and you find that the universe doesn't produce life. So you try it again. And you realize that it's really hard to create a universe that supports life. So what scientists have realized is these dials have to be perfectly set, many of them, for a universe that can create planets and stars and chemistry. One of the earliest ones to realize this was a man named Fred Hoyle. And Hoyle, what he did is he said, I noticed that in our universe is lots of carbon and lots of oxygen. That's really surprising, because if you look at how stars make elements, you just wouldn't expect that much carbon, unless there's several what he called cosmic coincidences. So to get the amount of carbon we have in our universe, you've got to have a half-life of beryllium long enough to combine with helium. So beryllium and helium combine to form carbon. A resonance level exists for carbon at the right energy to accelerate its production. So the energy of carbon has to be just right. So the energy of helium and beryllium come together, they hit that resonance level and produce lots of carbon. If it was higher or lower, not much carbon. In addition, the resonance level of oxygen is off from the product of helium and carbon by just the right amount. So if this energy level in oxygen were closer to the resonance, you would have too much oxygen. All the carbon would become oxygen. If it was too far off, no oxygen. So to have life, any type of life, you've got to have carbon, you have to have oxygen. In addition, if you try to combine oxygen into neon, that could remove all your oxygen, but there's a rule that prevents that from happening. So all these cosmic coincidences have to be just right, or there would be no life in the universe. In fact, if you look at all the details, it's not just that, but the mass of the electron, the proton, the neutron, the ratio of their abundances, the strength of the strong nuclear force, all these details have to be just right. And this led Hoyle to make a very interesting comment. What he said is a common sense interpretation of the data suggests that a super intellect has monkeyed with physics as well as with chemistry and biology. And that's key. This is an atheist. But when this atheist looks at the laws of nature, he realized that they look like they were designed with life in mind. And some of the details can be just about right. So for instance, if you want to get the right strength of the electromagnetic force, that'd be like a dial between, let's say, 1 and 20, and it has to be at a 17. If you want to get, let's say, the right difference in masses of protons and neutrons, that'd be a dial maybe 1 in 10 you have to get right. But other details are much more extreme, like gravity, for instance. If you look at the force of gravity, it has to be right to 1 part in 10 to the power of 35. That's a 1 with 35 zeros behind it. Now again, for you math-phobic people, once you get over your panic attack, let me just give you a little bit more of an analogy. How many of you like to shoot guns? You want to shoot targets? Okay, great. Imagine you've got a 1 centimeter target. How far could you hit that target? Who could hit that target in, let's say, 20 meters? Raise your hand. Okay, 20 meters. How about 50 meters? How about 100 meters? How about 10 kilometers? Maybe you're Jason Bourne and you get 10 kilometers. The precision necessary to turn gravity to the right setting would be like hitting a target at the other end of our galaxy. These are kind of the precisions necessary to get this right. It's not just that. If you look at the early universe, you have to get the mass right to 1 part in 10 to the power of 24. That's like a trillion. To get the expansion rate right is like 1 part in 10 to the 16. That's like a billion trillion. There's countless details that have to be perfect. But my favorite and the most dramatic is the entropy, which is like the disorder. The level of order in the early universe had to be right to 1 part in 10 to the power of 10 to the power of 123. So just to write that number, you'd have to have a 1 divided by a 1. You would have to put a 0 on every single atom in the visible universe. And you still couldn't even write that number. That's pretty precise. So again, as you look at the laws of physics, it's very clear that you see evidence that a designer didn't simply create the universe, but designed it with life in mind. Now, some people would say, well, maybe for us, it has to be finely tuned. But maybe there were other life forms. Maybe there was life made from silicon, like in aliens. Could that have been possible? And the answer is no. Because to get any life, you have to have chemistry. To get any life, you've got to have carbon. To get any life, you've got to have planets and stars. And if many of these details were slightly off, all you'd have is a universe filled with black holes, not very helpful, or a diffuse soup of hydrogen atoms spread throughout the galaxies. So again, you have to have these perfect to have any type of life. In fact, if you're curious, there's some really good books out. Luke Barnes has a great book called The Fortunate Universe. Also, Steve Meyer, who I work under, is going to have a book called The Return of the God Hypothesis, which will deal with this in more detail. That'll be out next year. But what's interesting is not just that these bulk constants have to be right, the right strengths, but they actually have to work together in a very careful way to produce things like water. Because to get water to have the properties it has, not only do the forces have to be right, but the sort of the masses, the physical laws to get water. And water seems pretty simple. You drink it, it's just a fluid. It's two hydrogen atoms with an oxygen. But water has numerous properties that are perfect for life. It has things like high specific heat capacity, and that's important. So water can absorb lots and lots of heat and not change its temperature by all that much. That's very unusual. It has a much higher specific heat than virtually any other molecule. And that's important because the fact that water can absorb so much heat means that the oceans stabilize the temperature of our planet. So you have these ocean currents that distribute heat across the planet, and that's why you don't freeze to death in Canada, or at least not outside of winter. Also, that allows us as animals to live because we absorb, because the water in our bodies keeps our temperature roughly constant. If that were not the case, we'd have serious problems. Low viscosity. So water can form rivers that flow through the earth. You've got ice sheets that can move pretty easy, and that allows water to be distributed across our entire planet. In fact, the hydrologic cycle depends on many unique properties of water. The fact it can exist in 3 different states in the temperatures that are normal for our planet is really significant. The fact I mentioned that it's got great mobility, so it can move across the world. Also what happens, it's perfect for leaching minerals from rocks, because what water does is it can dissolve in enormous numbers of materials. So that allows us to move the nutrients and the minerals from rocks, take them down to the soil so animals and plants can live. These are essential properties. If you look at water, the properties are amazing. The surface tension puts expansion on the surface tension plus expansion freezing breaks down rocks. Being an excellent solvent, it aids the leaching of essential minerals. The formation of carbonic acid further aids the chemical weathering of rocks. The low viscosity we've talked about, etc. So what happens is these unique properties of water actually help you to break apart the rocks and turn them into soil. So water actually delivers its own soil that allows it to hold itself to actually allow plants to grow. It's a perfect interconnected cycle. Incredibly beautiful. In addition, what happens is when you sweat, you give off lots of heat, because when water goes from water to a vapor, it absorbs enormous amounts of heat. So that allows us to thermoregulate our bodies. In fact, what's really interesting is that the organism that does this the best is humans. Because we have so little hair, we can be active for long periods of time, and because water will absorb so much of our heat, we're able to perform rigorous activities for long periods of time. Again, another perfect condition for life. Well, that's just the chemistry and the physics. Let's talk about our local environment. Let's talk about our planet. If you look at the planet Earth, there are countless details that have to be right to support life. It has to be the right distance from the sun, the right tilt, the right rotation rate. It has to have the right atmosphere, and the list goes on and on. Another one that's really interesting is because we've got a molten core that rotates, it creates a magnetic shield that protects us from the radiation from the sun. Without that magnetic shield, we wouldn't last very long. We've got plate tectonics. What happens is we've got these plates on the Earth that move, they kind of recycle themselves, and if we didn't have plate tectonics, we wouldn't have continents because they would all erode and go into the ocean. Without plate tectonics, we couldn't recycle things like carbon dioxide. So this is an essential feature for life to exist. Also the moon. The moon is the perfect size and the perfect distance from the Earth to stabilize our orbit. Without the moon, our orbit would destabilize, our tilt would wobble, and that would be very problematic. We'd have hurricane force winds and larger all the time. In addition, what the moon does is it creates tides which recycle the water in the ocean. Again, essential for the diversity of life that we have. If you look at our solar system, you have planets like Jupiter, these very large planets, and these planets were essential for our Earth to form in the right way. And what they also do is they absorb comets, they absorb meteorites. So without Jupiter, we'd be pelted with meteors all the time, which would not be a good thing. Our sun is highly stable, and it produces just the right type of radiation for life to exist. So our sun is perfect for life too. In fact, if it weren't so stable, if it was a different age, if there was other details, then you might get solar flares that would wipe out our life as we know it. We have the right type of galaxy, and we are in the right place in our galaxy to life to exist. If our Earth were closer to the center, we'd be bombarded by radiation. Things like supernovas. If it was too far out, our planet would not have the right materials to support technology and other essential aspects of what we're used to for life. Now let's talk about our atmosphere. This is one of the most amazing ones, because our atmosphere has the right amount of oxygen with lots of nitrogen, and that combination of gases is perfect for life. So for instance, what the atmosphere does is it allows light and heat to penetrate. And we need heat, obviously, to live, but we also need light for photosynthesis and to see. In fact, if you look at the electromagnetic spectrum, the part of the spectrum that corresponds to visible light and infrared heat is very, very, very small. It's teeny. Yet that's precisely what the sun produces. It's precisely what's let in our atmosphere. So here's more of a depiction. Here's this very narrow range of the energy that we need, and that's the same range that's let through with our atmosphere. Here's again the sun. You see the sun produces mainly visible light and some infrared, which is perfect. Here is the output of the sun, which perfectly matches our atmosphere and what's needed for life. And here's one of the most amazing examples, because our atmosphere it allows heat and light through, but when the heat is absorbed, what happens is the energy from the sun is absorbed in our planet. It's then re-emitted at a different frequency. And what happens is you see a window here that allows the heat to escape, because if this amount of heat couldn't escape, we would become overheated. If you let too much heat out, we would freeze. So the amount of the windows that allow the right energy in and the right energy out are perfectly set for us. Pretty extraordinary. And again, what you find also with water. Amazingly, water allows the right type of energy through. So this little spike of what water lets through. So water allows light to penetrate very deep. It allows heat to go through. And if that weren't the case, let's say water blocked the visible light, you wouldn't have the photosynthetic organisms that produced our oxygen, and that would be a very serious problem. The oceans wouldn't have the life we see today. So again, you see amazing coincidences where everything lines up perfectly with the radiation from the sun, with the energy that's let through both the atmosphere and water to allow life to exist. This is absolutely incredible, these coincidences. But there's even more than that, because it's not just that our planet was designed for life, but our planet is also designed for scientific investigation and cultural advancement. Think about this. The atmosphere doesn't simply allow us to breathe, but allows us to see the stars at night so we can do astronomy. Plate tectonics, the magnetic shield doesn't simply allow us to be protected from radiation, but allows people to navigate the ocean with compasses. What plate tectonics will do is it will take organisms that are buried on the bottom of the ocean and move them on top of mountains. So we can see organisms from the past because our planet was designed to give us an easy viewing window for them. You could go to Calgary and see trilobites and ancient creatures really easily if you go to the right parts. They're pretty interesting. But one of my favorite examples is that of vision, because what you find is the wavelength of light that's visible is not just perfect for photosynthesis, but it's actually perfect for the optics of our eye. Because what happens is when you look at light, imagine you have a certain wavelength of light. What happens is when light goes through an aperture, some hole, it has like waves that go out. And what happens is those waves determine the resolution that you can actually see with. So what happens is if the wavelength of light were longer, then everything would be much more blurry. So our eyes would have to be the size, the length of a football field or a soccer field for us to be able to see clearly. So the wavelength of light is just perfect for high acuity vision. In fact, what's interesting is if you look at the photoreceptors have to be a certain size in order to absorb the photons. So the maximum resolution that you can see with based on the chemistry perfectly matches the maximum resolution based on the optics and the wavelength of light. It's all interconnected for not just life, but for vision. And of course, another example is fire. So what happens is we don't just have the right amount of oxygen to breathe, but we have the perfect amount of oxygen to produce fire. Because if there is too little oxygen, we wouldn't be able to produce fire. If there was too much, we'd burn down the forests, kind of like in California these days. And also, we have nitrogen in the atmosphere that acts like a fire retardant. So if you have pure oxygen and you light a match, it's going to blow up the room. But we have just the right amount of nitrogen to slow the burning of fire so that it's containable, it's controllable. Again, it's ideal for technology because to advance technologically, you have to produce fire to basically get molten metals to produce tools. Now, of course, chimpanzees don't do this. So this is a big example of fine-tuning specifically for intelligent agents like ourselves. Now, there's some great books on this. The Wonders of Water is a really nice book that talks about it by Michael Denton. I'm actually using some of his slides. The Children of Light and then Firemaker are some beautiful books by Michael Denton. He's the world expert on these topics. Now, of course, what I've dealt with is the issue of design in nature. The laws of physics are designed for life. Our planet is designed for life, and I'll talk about the origin of life later. But how do people respond to this? Well, there's a couple of responses. One is you could say, wow, I see evidence of a creator outside of time and space which designed the world for us. The other response is, well, we've got to rationalize this away. So the common approach is the multiverse. It's the idea that there's like an infinite number of universes. So we just won the cosmic lottery. We're just lucky that we happen to be in the right universe with the right laws. But there's so many universes, it's not a big deal. Kind of like a Rick and Morty episode. But what happens is the multiverse theory has some serious issues which I'll go into. In fact, let's just talk about where it came from. Part of the reason people came up with these more exotic theories is they noticed the fine-tuning that I talked about before. Now, one example of fine-tuning is that if you look at the cosmic background radiation, that's sort of that 3-degree radiation that's coming at us from all directions, they found it was unusually uniform. And they also found that our universe appears to be fairly flat. Now, what do I mean by that? Well, if you have a certain density for the universe, what happens is space curves in a certain way. If you've got much less of density, it curves in a different way. And that's important because what happens is if the universe is very, very dense, it will expand and it'll recontract. So that's like a closed curvature universe. It expands and contracts. If the universe had much less density, then what would happen is you'd have particles that would just fly into space very quickly, and there would be no planets or things like that. So the density of our universe is just perfect to allow things like stars and planets. So the question is, how do you explain this? So to explain away this fine-tuning, people came up with the idea of cosmic inflation. Now, inflation is not what happens to your paycheck if your dollar value drops. That's not what's going on. Inflation is, in the early universe, what happens is people believed that it expanded incredibly quickly in a very short amount of time. And this inflation is a way people justified the fine-tuning, because inflation can explain away things like the flatness, it can explain away the cosmic background radiation, the uniformity. And also, inflation has an idea called eternal inflation or chaotic inflation. And the idea is that when our early universe started to expand very quickly, it would spit off all these different universes with different laws. So the idea of this cosmic inflation produced lots of universes with lots of different laws. And that's how you explain the fine-tuning. There's a problem. In fact, this was talked about by a physicist named Steinhardt in his paper, Pop Goes the Universe. And Steinhardt was one of the architects that created cosmic inflation. So he's one of the world experts. He said, to get inflation to work, you have to basically fine-tune all the details of this model to make it work. Like inflation can do just about anything. So to actually have an inflationary model to produce a universe like ours, you have to fine-tune the details of it to make it work. So what happened is, to try to explain away the fine-tuning of our universe, they appealed to a theory that also had to be finely tuned. The same thing is, there's something called the string landscape theory, and please forgive me if this is all technobabble to you. I just do it to make me look smart, you know. But what happens is, you have this idea where you apply string theory to cosmology. And again, one model is, you've got what are called these brains, which are like these sheets that bounce into each other. And every time they bounce into each other, they produce a new universe with new laws. The problem is, that theory also has to be finely tuned. One version had to have the placement of the brains at 1 part in 10 to the 60th. That's a 1 with 60 zeros behind it. So basically, every attempt people have to envision all these multiverses, when you look at the mechanisms to generate all these universes from the multiverse generator, it also has to be finely tuned. So it's kind of like, any of you ever try to put carpet in your house, but the carpet is just a little bit too big? What happens? You get a bulge in the middle, right? What do you want to do to that bulge? You want to take a big hammer and hammer that bulge. Do people know what I'm talking about? But when you hammer that bulge, what happens? Because the carpet's too big, it appears someplace else. It's the exact same thing in physics. When you look at nature, you see evidence of fine-tuning, purpose. And to explain it away, people have come up with all sorts of exotic theories, but those theories also have to be finely tuned. The bulge just goes someplace else. You can't escape it. And why is this significant? Well, let me use an analogy. Imagine that you're hiking in the mountains, at Banff maybe, and what happens is, you come across this cabin in the woods. And this cabin you enter, and you notice it has your favorite food in the refrigerator. And that's kind of nice. You appreciate that. You go to the closet, it has your favorite clothes that perfectly match you. That's strange. Maybe it's a coincidence. You go in, you notice it has pictures in the living room of your family and friends. Okay, now you're starting to freak out. It's some sort of horror movie. And now you look, there's a phone, and your best friend's numbers are programmed into it in order of your preference. Now, what would you think? Would you think, what an amazing coincidence? I was just really lucky I happened to come across this cabin, and maybe my relatives did like stock photos, and they ended up in this. I mean, no. You would know somebody knew you were coming and prepared this cabin with you in mind. In the same way, when you look at the laws of nature, you look at the details of our planet, our solar system, what you see is evidence not just of design, but a design specifically with life, humans, in mind. That's key. Because you could argue with our planet that maybe there's just such a big universe that our planet is just lucky. But the problem is, we could imagine that we appeared on a planet where you could only live between, let's say, 20 degrees north and 20 degrees south of the equator, right? It's not just that our planet allows for life, but it's so optimized for life. It's perfect for life from the equator to the poles. It's perfect for scientific investigation. So when you look at that, again, you see that we're not just a lucky accident, but someone had us in mind. So when you look at all the laws of nature, when you look at chemistry and physics and biology, you look at planetary science, it all points back to an intelligent creator. In fact, there's a great verse. This is from Psalm. It says, "The heavens declare the glory of God, and the sky above proclaims his handiwork. Day to day pours out speech, and night to night reveals knowledge. There is no speech, nor are there words whose voice is not heard. Their voice goes out through all the earth, and their words to the end of the world." Because again, as the Apostle Paul said, God created our universe in such a way that the appearance of design is undeniable. And the choice people have is they have to envision an imaginary multiverse with infinite possibilities. It's not based on a shred of scientific evidence, or you could simply follow the evidence where it leads to an intelligent creator. Thank you.